Hello, on this worksheet we're talking about pedigree analysis. So pedigrees are kind of like big family trees that can be used to show inheritance of specific traits or even diseases through different generations. First, a little bit of background information. Circles represent females. Squares represent males. If they are shaded in, then that represents them having whatever disease or trait that we're looking for. Now, these can also be given letter genotypes to help us work through this. So, for example, if this is a dominant disease, then it would have large letter genotypes. Let's start a bit simpler though. Children are shown by lines branching down. Marriages are shown by lines branching across. So, for example, how many children did individuals 1-1 and 1-2 have? We're counting these by the Roman numerals on the side. That's generation 1, person 1, married person 2. They had one child. They have one direct line. Here, that was married. They have 3 more, 5, 6 total offspring. If it's shaded in, that means that they have this genetic disease. There are 3 shaded. How many daughters did 2-1 and 2-2 have? They have 2 circles representing 2 daughters, 1 son. I'm going to skip down some. It asks to write the genotypes over all known individuals. You can determine that all of them that are shaded have big W's. Most that are not shaded will have small w's. These will all be small w's. Now, is this a dominant or a recessive trait? It's going to be a dominant trait. There are no carriers. You either have it or you don't. If you have it and it's passed on to an offspring, then it's dominant. If you see it in every generation, which we do here. So dominant, I'm going to make a little note, every generation. Let's see, let's do one more. This is a pedigree showing disease tracing for hitchhiker's thumb. You do not see it in every generation, so it's recessive. I just told you this one, it's not present in every generation. So we want to write our genotypes above individuals either using big T or little t. There's only some that we know. It's a recessive trait. So if they have it, they're going to have little letters. Because these have little letters and they're shaded, but these are not shaded, we are going to assume that they can be carriers. If it's a carrier, then it's partway shaded, so this genotype would be big T, little t. These parents' offspring does not have the recessive trait, so we know that they are probably going to have our large phenotypes. Remember, lines between 2 mean that it's husband and wife. This is their child. This would be her parents, her brother. Number 11 asks us, is it possible for individual 4-2 to be a carrier? It is possible because if you do a Punnett square between the 2 parents, then they're both carriers. you find that they have a 50% chance of becoming a carrier. So yes, it is possible, because they can inherit the carry trait from their parents. Alright, that leaves you with just a little bit left on your own.